Grüezi YouTubers, here is the guy with the Swiss accent. Today you find an innovation at the end of this video, and it has to do with this ESP82 development board from Analog Lamp. In the last episode I disassembled this Sonoff SC and did also some tests, some debugging. Here we have the ESP8266, here we have the Mega 328, and they are connected here with a serial connection. And we can basically take away these two jumpers, and then we have two independent processors. And we can program them either by serial connection with a bootloader, but I checked, there is no bootloader here. This is why I soldered this ICSP connector here. Then I can program the Mega with this ICSP programmer. We will see later on how this works. Okay, now this one has to be anyway programmed through serial, and this button here is a GPIO 0, so we can use this one to put it in programming mode. This is what I found out over the last few days. But to program these two and to work with them and with this connection and so on, that's not how I want to do this. And in the meantime I found also a alternative firmware for this device made by Tinkerman. So I want to try to put this, or a version of that, on this device. It has MQTT on the ESP8266, and the sensors are managed by this Mega chip. But to deal with this whole situation, I decided to go a completely different way. I do not use this to develop or to debug or to understand the software of Tinkerman. I put this away, and I have here my normal Lolin board with the ESP, which behaves quite similar to this. So this is the emulation. It just has a different flash size, but that doesn't matter for the moment. And for the Mega, I use an Arduino Mega. And why do I use Arduino Megas for this purpose much more than the Unos? Because they have more serial connections. And in general I use serial, the normal serial without the number, I use for the monitor, for the programming monitor, and then I still can use another serial to communicate with this device. But if you look at the two devices, I think most of you know that we have a small problem here. This one is 3.3 volt and this one is 5 volt. And now, if we want to connect this, we can go from ground to ground. That is no problem. And then if I would like now to connect the RX with the TX and vice versa, then we might not do that. At least this is what I thought up till last week or 2 weeks ago. And then the head of Espressif, the CEO of Espressif, twittered that the ESP is 5 volt tolerant. So we do not have any more to fear that we kill the ESP if we go with 5 volts on its input pins. So we really can connect these two. But for the moment I do not want to connect these two because I do not like too complex systems for the understanding of the systems. This is why I take this away and I start with the Arduino stuff. So I emulate only this area here, and this is similar processor, and I use just a serial connection, and I connect this one to here because the serial connection I know quite well what it does. So I put it here on RX1 and on TX here, and the TX1 on RX. Now I have connected this one to serial 1 and to serial 1 here, and I can use, for example, PuTTY or something to work with this. And I also brought my laptop here. You just see a small thing, and this has also a reason, because if we want to program the ESP and an Arduino, then we always have to change the board definition of our IDE, and I don't like that. I want to have one board definition during programming, because otherwise you have to change it all the time. It's not interesting. That's why I have now an Arduino IDE on my laptop and one on my normal PC. One is for the Arduino and the other one is for the ESP. So we are for the moment set up. I downloaded already the files from Tinkerman, and the files are already here, and now we can check what this device does. And then I have also the other files on this ESP. So basically Tinkerman has two files. One is for the ESP and one is for the Arduino, and I check what happens here and what happens there, and I show you now in the serial monitors what how they behave. Here I have now PuTTY, which is connected via the serial connection to TX1 and RX1 of the Arduino Mega. So I want to check how the Arduino program or the Arduino sketch from Tinkerman behaves. I have no sensors there, so I do not expect any values, but I just want to know what it does. And for that I just reset it. AT plus hello equals 1. Again, nothing special. And we see also here that it is just a line feed. It's no carriage return. Otherwise, if we would have a line feed plus a carriage return, then the next AT command would start here. Usually at the end of a line you have either a carriage return or a carriage return and a line feed, or a line feed. Here we don't learn too much. So it is clear that the Arduino is the slave here in this concept, and the ESP is the master. So we have to check what the ESP sends to stimulate the Atmega. Otherwise we will not find out what happens on this. Now I connect the ESP and I look in serial monitor, because there I will only use one serial connection and I will use just a serial monitor. So I have here the serial connector, which is connected to the ESP and the ESP has now Tinkerman's ESP program loaded, and we will check what happens here. I just reset. It creates a lot of information here, and I think it also opens a hotspot. So I try to connect to this hotspot. I'm still connecting to the hotspot, but now we got some AT commands here, which is very interesting. AT plus every equals 10, AT plus clap equals 1, AT plus push equals 1. So these seem to be the commands which are sent by the master to the Atmega chip. Now we can go back to the Atmega and stimulate the Atmega with these 3 commands and check what happens. Here I'm now connected to the hotspot and I get the authorization request from the ESP somehow. I don't know how this works so far, but it's I need a password and a username. So I leave this for the moment. I want to understand the interface between the Atmega and the ESP, and this is why we can close this and concentrate on that. And here we saw the web server. Now I again open PuTTY and AT. I can do it differently. Does not do anything. And we saw before that it needs probably a new line or a carriage return, but probably a new line. And this we have to change in PuTTY. So here is PuTTY, and I think we can change it here. So we do this one here, for example, that we get the carriage return and the line feed together probably. And we put also local echo that we see what we type. And we need COM10 and so again nothing happens. Now with the next one nothing happens, and the last one nothing happens here. So probably we have to have more than just this one. So we do terminal, this and echo and serial. So we always get 2. This is probably the echo. Nothing happens. I just switch off this echo because I don't like this. Now it looks nicer, but nothing happens. I forgot to switch the Atmega on. Now we can try again. You see, I make also mistakes. Now we take this one. Now we got OK, or what? Invalid? OK. So we really need the echo. Now we can try again. Now we get 80 plus every equals 10 is okay. So we get an answer. What about the clap? We get also an answer. And here we get also an answer. Now let's try once. Ah! We get more. Now we get temp, humidity, dust, light, noise. Good! This is what I like here. I do not have values, or at least strange values here, but this is clear. I have no sensors on the Arduino Mega. But now we see what we need. One of these commands here stimulated the Arduino Mega to send us the information. And now we just have to send, I assume it's this every 10 seconds, because we see it is every roughly 10 seconds we get the values. This is what we have to send from the ESP to the Arduino Mega, and the Arduino Mega will answer with this string. And we just have to parse this string and then send it to our MQTT broker. I try to use Tinkerman's program as much as possible, but this is quite a huge thing there. He has plenty of libraries and stuff like that. And of course, I want to have it on IoTAppStory.com infrastructure. Also, I want to use it with a Wi-Fi manager. I think Tinkerman uses also a different web interface, and so I don't know how much I can use of Tinkerman's coding, but I switch off now for the moment and try to start a little bit coding, and then I come back, and then we can test further on if we can solve the issue here. As promised, I'm back now, and I took Tinkerman's code and implanted it into my so-called virgin soil sketch. I was able to use two parts of his coding. He has the main sketch, as we would say, then this is from me, the IoT story helpers file, and then the comms file and the MQTT file, both were usable for me. The rest I skipped. And I think now first we have to focus on the comms. And in the comms file we see what we saw here, these commands here. And what the comms file does, it reads serial and detects these values, and if one of these values come, it then separates the value. And it's loaded now on the ESP, and if I start the ESP, this is from IoTAppStory.com, and now nothing happens. It's just waiting for a command. So let's give it the command here. So I emulate now the Arduino. The Arduino, which will send a value. And the value is 80 plus light equals 25. Now let's look what the ESP does with it. So it has the command, and it has also the 25, and it triggers the MQTT interface and wants to send the light Q and the value 25. So we are quite advanced in our ideas to read the values from the Arduino and send it to the MQTT broker. Tinkerman uses not the PubSub MQTT library, he uses a different one I never saw, but I do not want to change it for the moment. It is async MQTT client. Here my strategy is to change just what is really necessary or to keep as much as possible, because I'm sure this guy is good if I'm looking at his programs, and it would save me a lot of time if I can take what he already did. So let's summarize the current state and the future plan. We have this Sonoff SC board, which consists of a 80 Mega 328p processor, which drives different sensors. And on the other side we have this ESP8266 device, and they are connected by a serial connection, which we can separate if we want. I found a code from Tinkerman which has part 80 Mega code and a part ESP8266. So far we found out what the 80 Mega code makes, and we have an idea what the ESP8266 code should do. I think I can keep this 80 Mega code. Maybe I want to change one of the sensors and then we have to adapt it a little bit, but I assume that I have to change a considerable part of the ESP8266, which then should connect to an MQTT broker. I will use CloudMQTT today as an MQTT broker because I still do not have my own MQTT available in my lab. The code here has to be a blend of Tinkerman's code and the IoT App Store infrastructure. And this is what I want to build now, and then we can test everything on the breadboard. So we check now what happens with these 4 lines of code here inserted in the Virgin Soil general file from iotappstory.com, and we see here it is connected to the CloudMQTT server. And now we see here the CloudMQTT console, and there is nothing here. And now I simulate or I emulate the Atmega and upload one measuring result of a sensor, AT plus noise equals 20. Wow, this was fast. So the noise channel is 20. AT plus incredibly fast. Nearly immediately we get this information to this MQTT Cloud Console. So obviously our concept works. So summarize, what did we achieve today? We were able to write a sketch for the Atmega, and we were able to write a sketch for the ESP. And why did we do that? Because we have here the same processor or a very similar processor as the Atmega and the Arduino Mega, and here we have an ESP. And now we basically have simulated or emulated the whole Sonoff, but with more suitable platforms which can be handled easier than here. And now the next step will be to put the sketch on the Atmega chip and to put the sketch on the ESP. And then we can connect it here and the whole thing should run. I think I will also change this sensor here because the DHT22 seems to be a better choice, and this is just hot glued here, so it shouldn't be a problem to change that. And then I have to change slightly the library here of this sketch, that it understands the DHT22 and not the DHT11. But this is for next time. Now we go to the innovation. Guys who watch my mailbags might remember this board. It is an ESP32 development board delivered from Analog Lamb. This is a new supplier to me. This is the first board I got from them, and they delivered quite fast and they had it in stock. Now they ask me if I want to have some boards for me, for my work, and I said no, I don't need. I have already a few of them, and I made the proposal that I can give away some of these boards to my valued viewers. So today I announce a draw of 3 of these boards, which will be shipped from Analog Lamb directly to you, to the lucky winners. I will draw the winners next Friday, January 27, 2017. I will draw the winners from all people who use IoTAppStory.com and which already did a project. So I get a list from Ono with all users of IoTAppStory.com which have an active project. And then next Friday I will draw with a random generator 3 lucky winners, and they will get directly from Analog Lamb one of these boards. Good luck! I hope this video was useful or at least interesting for you. If true, then like. Bye!